This podcast is on the particles in the atom. Each element in chemistry is unique, and to understand why, you need to know about the parts that make them up. There are three particles in the atom. I'm sure you know this. They're the electron, the proton, and the neutron. We will be using the symbols shown E-, P+, and N0 to represent them. The electron has a -1 charge, the proton a +1 charge, and the neutron is neutral or uncharged. The electron is significantly lighter than the proton or the neutron, and the actual mass measured in grams, you will see, is in the range of 10 to the -24 to the -28 grams, which is obviously quite small. Now, the atom has two main regions: the nucleus, which contains the protons and the neutrons, positive charge, and almost all of the mass of the atom, and it is surrounded by an electron cloud, which makes up most of the volume of the atom, and that is the region where you find the electrons. Now, atoms are incredibly tiny. Measured in picometers, they're about 32, and that is 10 to the -12 meter is a picometer. The nucleus is even smaller. It's about 10 to the -15 meters. It also is incredibly dense, density approaching 10 to the 14th gram per cubic centimeters. It is said to be quite massive. If the atom were the size of a stadium, say, then the nucleus would be about the size of a marble. It's just an analogy to give you some sense of the sizes. In chemistry, we use symbols to represent elements. This is the classic symbol for the element fluorine. What do all the numbers mean? Well, you'll be asked to find the atomic number, which is 9. It's the number on the bottom. The mass number is the number on the top. Now, the number of protons always equals the atomic number. In an atom, the number of electrons also equals the atomic number. And you have to calculate the number of neutrons. The number of neutrons is calculated by taking the mass number and subtracting from it the number of protons. So in this case, there are 10. Chemists also have ions. Here we have the symbol for the sodium ion. Notice the plus charge to the upper right. Well, the atomic number is 11, the mass number is 23, there are 11 protons, and there are 12 neutrons. And the charge is +1. Well, how many electrons does it have? Because it's charged, the number of protons and the number of electrons are not equal. So to calculate the number of electrons, you take the number of protons, or the atomic number, and subtract from it the charge. And we will get here a charge of 10. So again, for ions, the number of electrons equals the number of protons minus the charge. Let's look at the negative sulfide ion. Here the atomic number, mass number, protons, neutrons, charge are all known. The number of electrons is equal to the atomic number or number of protons minus the charge, which is -2, which is actually +2 to give us 18 electrons. And so you see the same method works regardless of whether the ion is positive or negative. Remember, the mass number is always a whole number, and you will not find it on the periodic table. Isotopes. Isotopes are atoms of the same element which have different mass numbers. The number of protons is the same, therefore the atomic number is the same, but the number of neutrons is different. Here we have carbon-12 and carbon-14. Looking at 3 isotopes of magnesium, you'll notice that you have the same number of electrons in all, the same number of protons in all. If we look at the atomic symbols, though, we can pick up the fact that the mass numbers are 24, 25, 26, which means that the number of neutrons is what is different. We have 12, 13, and 14 neutrons present in those 3 different isotopes of magnesium. So we need to keep some terms straight. Atoms differ by number of protons, ions differ by number of electrons, and isotopes differ by number of neutrons. And we might as well end with a little cartoon.